ones. Okay, so these 3 questions of integration is to really see whether you know how to do integration or not. First thing first, right? When you see a square root with a quadratic at the bottom right, you must think of sine inverse. Okay, you must think of sine inverse fx. Because integrate a square root with a quadratic inside, there is a sine inverse involved. Okay, for this kind of question, I did say before, number one, always think of, now there's a square root on top. Or the first thing, always think of f prime x over fx, or f prime x fx to the power of n. Okay, so in this case, it is a square root, so this is not going to be the one that is going to be used. This is the one that is going to be used, because can you see square root means power half? Yeah, it will become like a reverse chain rule down there. So when we integrate this, you have to know that when we integrate this becomes fx to the power of n plus 1 over n plus 1. Now all these are supposed to know for the integration technique. That's how we start. Okay, so first I write fx, don't care about the square root, 7 minus 6x minus x squared. Differentiate this, I'm going to get minus 6 minus 2x. It will be somewhat related. Can you see the numerator is minus 5 minus 2x? But your f prime x is minus 6 minus 2x, right? So how we're going to start is, okay, negative this over the square root of 7 minus 6x minus x squared dx is going to be equals to, I want it to be minus 6 minus 2x over square root 7 minus 6x minus x squared. But these two, are they equal? No, I need to compensate with a plus 1 over square root 7 minus 6x minus x squared dx. This is how you start. Okay, once you have this starting position, then it is easier to do in the sense that, okay, so I'm going to bring it up as linear. Minus 6 minus 2x as well as 7 minus 6x minus x squared to the power of negative half. Okay, I'm going to bring this up first. Plus, okay, this guy, you need to have this skill of doing it concurrently. If you don't want to do it concurrently, that's fine. You have to know that, okay, this guy, I'm going to complete the square, plus 6x minus 7. Okay, I'm just going to leave this guy here first, okay? Because y'all can only manage one thing at one time, right? Let's settle the left side guy first. At the start, I already realized, okay, this guy is inside. It's called fx to the power of negative half. Can you see? Differentiate inside. This guy is already at my f prime x, right? Yeah. So I can just apply integral of f prime x fx power n is fx to the power of, so what's my fx? 7 minus 6x minus x squared. Increase the power by 1. Divide by the new power. Okay? Yeah. So I'm going to leave it as this. I can make it nicely. Divide by half means times 2. So this will be 2 square root 7 minus 6x minus x squared. And then this is my answer for the left side. So you must identify, if it's square root, you must use f prime x fx power n. The integral of this. Okay, if there's no square root, then usually it is f prime x over fx. The integral of f prime x over fx, so you must know this one very well because it comes out in a lot of questions. Ln modulus fx. Okay, so for the ln one, maybe later it might come out, or rather it actually didn't. Okay, now look at this. When you see can you see the numerator is a number? So it goes back to two things. The numerator is a algebra. Think of f prime x over fx or f prime x fx power n. The numerator is a number. Then it's straight away an inverse sign. How to know that it's inverse sign? You got to do complete the square. 1 over square root the negative x squared plus 6x plus 3 squared minus 3 squared minus 7. Okay? Then I'm going to do some more. So this is plus the integral of 1 over the negative, just put on the outside. These 3 guys completes the square, right? By this time, you all should be very good at completing the square. Okay? This guy is minus 16. Okay? Yeah. dx. All this that I already done, I'm going to continue writing 7 minus 6x minus x squared plus integral. So now I effect the negative go in. You have to do so much that you know that this is 16 minus x plus 3 square dx law. Okay, now usually this will be a nice square number. 16 is 4 square, right? 4 square, right? Yeah. So if you look at your MF 27, the integral of 1 over a square, Okay, sorry, I see. Even I also forgot that I skipped the square root. There's a square root there. Okay, yeah. The square root of a square minus x square dx is equals to inverse sine x over a plus c. This is given in your formula sheet, MF26, MF27. So the final answer is 2 square root 7 minus 6x minus x square plus inverse sine. Be careful. This is x plus 3. Don't write over 16, okay? Because it's 4 square over 4. Then plus c. Okay, so many learning points down there. How to split when it is algebraic, must always look at the f prime x first. Then you determine whether is it ln or reverse chain rule. Okay, then the next one, it will always be a number over either square root 1 or no square root 1. The denominator, as long as it's quadratic, you have to complete the square, or if you got no square root 1, we can still do partial fraction. Later, I'll try to show you some examples, which actually last week we go through a few already. Okay, can? So this is for a usual kind they will ask. So if you look at B, they ask you to integrate x over square root 4 minus 2x dx. And it's a substitution. U equals to 4 minus 2x. The first thing that you have to do is to go and differentiate this. Oh, du dx is equals to negative 2. This part can understand? You need to make dx the subject by using your pencil. So cross multiply, du is equals to negative 2 dx. I make dx the subject, dx is equals to du over negative 2. Or you can write it as negative half du. Bring the negative 2 over. Okay, so this is your starting position. Now, you also realize that there's an x, right? The red one I write means you have to use pencil to write, okay? X is equals to 4 minus u over 2. Now we can do it proper. Okay, so this is the integral of, my numerator is 4 minus u over 2. Then there's another over, square root of 4 minus 2x, that is square root of u. Dx, don't forget, dx cannot just change to du, okay? Must write as multiply by negative half u du. Okay, this part understand? The dx must change to this. That's why we do this. Okay? Can? Say again? Not half u, sorry. It's half. Yeah, thank you. Now this part is going to get complicated. So for those of you who are not very good at manipulation or going to get careless, right? When you see over, what is another operation of saying over? Over also means, sorry. Over also means divide, lor. This part can understand? Divide means multiply. You can only flip the right side one, and remember, you can only flip the right guy. Okay. Now at this point, you can take out. Can you see there's an over 2 and then there's over 2 here? If you're not confident, then you can multiply in. So this is over 4 with a negative. Can you see the over 2 and the over 2 negative? I can multiply in. Multiply by 1 over u power half du. This part can understand? I multiply this to here. Then I'll get. Can you see I get it? As long as you have a constant. So, Yingxuan, I see you take out an x, right? You cannot take a variable outside of the integration sign. Okay? If that is too cool for you, then move back to your regular seat. Okay? Later. So, we take out a 1 over 4 here. Negative. Integrate. 4 minus u. Again, this is multiply, right? No need to make common denominator because it's multiplying. Usually substitution, right, will not require you to do a bypass in the substitution. Okay, it will usually be easy in the sense that this is going to be 1 over 4 over u power half minus u over u power half. Okay, this part can see you can only split if the numerator got 2 terms and the denominator got 1 term. Okay, yeah, then okay, I'm just going to draw a line here. I'm going to write up the equal over here. Equal negative 1 over 4 integral, I'm going to make it linear, 4u power negative half, u to the power of 1 divide u to the power of half is just u to the power of half du. Negative 1 over 4, integrate this, 4u power half, increase the power by 1 over the new power. Can see? I increase the power by 1, yeah, over a new power. This one, increase the power by 1. 3 over 2. Over 3 over 2. Plus c. Okay, make it nice. Negative 1 over 4. 8u power half minus 2 over 3u power 3 over 2. Okay, plus c. If the question gives you like a definite integral, then you just sub the definite integral in. If not, we have to put it back. So this will be negative 2u power half plus 1 over 6 u power 3 over 2 plus c. Okay, what was u equals to? U is equals to 4 minus 2x. Can see at the top? So put it back. Negative 2, you can just put as 4 minus 2x to the power of half plus 1 over 6, 4 minus 2x to the power of 3 over 2 plus c. Okay, and that is it. Okay, so remember a few steps. The first part, always differentiate. Make dx the subject first using your pencil.
Wait, so you don't use like long division? So like u1 equal.
Don't need, because the numerator is bigger than the denominator. We always split it. If you do your long division, especially when there's u power half, we don't do long division. Okay? Can? Very weird. Yeah. Yeah, gonna get very weird. Correct. Okay, so that's for substitution. All right. So the last one, obviously, is a by part. So there will be 3 kinds of question. One is a fraction, one is a substitution, and one is a by parts. Okay, so the last one is by parts. The integral of x tangent inverse 3x. Okay, dx. Now, obviously, I know that. So first thing, what are the 5 alphabets I write here? L-I-A-T-E, right? Yeah. L-I-A-T-E is to choose your u. Okay, but if you look at this, it's quite easy to understand who is my u, because can I integrate inverse tangent? Cannot, right? This guy can only differentiate, right? Yes. So this is u, and then this is v prime. Okay, so what is the formula of by parts? You have to write at the top first. Integral of u v prime is equals to uv minus the integral of v u prime. Okay, this one have to know. This one have to know. So with this, I'm just going to put it here. Now, it's always opposite one. Tangent inverse 3x is here. Okay, and then x is here. Most of you can actually do this correctly. Integrate x, I get x squared over 2. Differentiate tangent inverse is in my formula sheet. 1 over 1 plus 3x bracket square. Remember to multiply by differentiate the angle 3. Okay, so this guy is actually called 3 over 1 plus 9x squared. So I'm going to apply the things. uv, where is uv? This is uv because this is u and v. So I'm going to write down, this is x squared over 2 multiplied by inverse tangent 3x minus the integral of vu prime. So who is v? Tangent inverse, and then, sorry, u, the other way, label wrongly. Yeah, correct. Okay, so this is u, this is v. vu prime, you see, we will always cross the other side. So this guy is a little bit complicated. X squared over 2 multiplied by 3 over 1 plus 9x squared dx. Okay, this part is done already, so we're just going to continue writing this. Inverse tangent 3x, okay, minus 3, you see it's multiplied, right? You can of course put it as 3x squared over, don't multiply the 2 inside, 2 bracket 1 plus 9x squared. But in this case, what should you do? Take out the 3 over 2, put it on the outside, is nicer. Okay, now you come to here. Yeah, you realize that it's a fraction, right? The integral of a fraction, right? Now look at the numerator. Can split or not? Cannot, because on top 1 term, bottom 2 terms, right? So this is the time where you go and do long division. Write 9x squared plus 1 here. Times what to get x squared? 1 over 9. So I will have x squared minus 1 over 9. Put a minus and then a bracket. You get the remainder is 1 over 9. Okay, a bit hard. Integral, so this is the quotient plus remainder 1 over 9 times of 1 plus 9x squared. Can see? Okay, can see? Can see? Yeah, so this guy is just going to be keep on down here. tangent inverse 3x minus 3 over 2. Integrate 1 over 9 is just going to be 1 over 9x. Okay, can? Plus, okay, this one a bit tricky. The 1 over 9 keep on the outside, right? Integrate 1 over 1 plus 9x squared is 3x squared, right? Okay, so look at your MF again. A integral of a plus this one. Now, okay, this one is a little bit hard. Maybe we can take out the 9 and then it becomes 1 over 9. I teach you how to use the MF to help you. Okay, can you see this is 9x squared? I take out a 9. I'm going to left with 1 over 9 plus x squared. Can see here? Okay, make sure if you want to use the MF to get your integral, right? So the MF integral say the integral of 1 over a square plus x square dx is equals to inverse tangent x over a. I think there's a 1 over 2a on the outside. I'm not very sure because I also refer to the to the MF 27. So make sure your x is here. So this is x squared over 2 tangent inverse 3x minus 3 over 2. This one just keep it there, 1 over 9x plus 1 over, so you see the 9 can take out 81. Can you see 81 here? Okay, so now I'm left with integrate of 1 over 9 is 1/3 square plus x square dx. So I'm just going to use my MF27. Can you see x squared plus a squared is 1 over a tangent inverse x over a, or 1 over a tangent inverse x over a. X squared over 2 tangent inverse 3x minus, this one can times in 1 over 6x minus, this one can times in 3 times 9, okay, 27 times 2, so this will be 1 over 54. So integrate this, I just use this is my a, this is my x, okay, this will be 3 inverse tangent of 3x plus c, okay, because it's 1 over a, the a is 1/3 ma. Multiply here, multiply here. Multiply here. Okay? Can? Yeah, something like that. Of course, I think it will be easier. This question is just an off my head example. Okay, which I'm going to do one more with you. Ryan, can you look at your paper, right, and tell me the one? Give me the paper that you're doing. Hurry up, hurry up, hurry up. The school one, yeah. Okay, so you see there is two more I want to talk about, which is 6C in the 2022 EJC promo, integral of x over 4x squared minus 4x plus 17 dx. Okay, so first go and use your mode 522. Go and, anybody got calculator, come use mode 522 and go and tell me whether you can put it nicely or not. Can factorize nicely? Cannot, right? Then you will be complete the square. Okay, but I want to make it such a way that it can factorize nicely. So I'm going to change the question a bit, right? So look here. So let's say this is x squared minus x minus 6. Okay, so always check. Okay, now is there any square root at the bottom? No square root, right? No square root means the sine inverse out already. It's either tangent inverse, okay, or whatever thing it is. So look here, this guy, right, can be factorized, right? Can become x minus 3, x plus 2. Listen, guys. Okay, first you must know that, okay, this guy can be factorized. Okay, so this, my f prime x over fx still do it, because you see the numerator. Is it algebraic? Yes, right? Algebraic means you still have to do f prime x and fx first. X squared minus x minus 6. Differentiate this. I get 2x minus 1. Can see? Okay, can? So I need to have a half here. Integrate 2x over here. X squared minus x minus 6. This part can understand? Because top and bottom must be the same. Yeah, but I want to have a minus 1, right? Okay, so I'm going to give a minus half integrate 2x minus 1 over x squared minus x minus 6 dx plus the dx to right here, because I want a minus 1 to be the top, okay? Then plus 1 over x squared minus x minus 6 dx. Can you understand? So first thing, I need to multiply by 2 to the numerator, so I must have a half on the outside. Because why? My f prime x needs to have a 2x. This part understand? Then my f prime x is a 2x minus 1, right? I can add, if I want to minus 1, I must plus a minus 1 on the other side. Okay? Then it comes to here, very obvious. This guy is my fx, right? This guy is it my f prime x? Yes, right. So integral of f prime x over fx, the first one is easy. It's just going to be ln modulus x squared minus x minus 6. This part can I understand? Can I? Plus, now I'm going to integrate this. So remember, just now, this part, can put partial fraction, right? Yeah. So this is where now you have to use a pencil. Partial fraction 1 over x minus 3, x plus 2 is equals to a over x minus 3 plus b over x plus 2. Cross multiply this part. 1 is equals to a times x plus 2 plus b times x minus 3. Okay? Let x equals to negative 2. I will have b is equals to negative 1 over 5. Let x equals to 3, my a is equals to 1 over 5. Okay, so if the denominator if the quadratic can factorize, right, you have to do complete the square. So this guy just keep on writing half ln modulus x squared minus x minus 6 plus the integral of a is 1 over 5, right? 1 over 5 x minus 3 minus 1 over 5 x plus 2 dx. Okay, this part can understand? Split it to partial fraction. Then this will become ln modulus x squared minus x minus 6 plus the 1 over 5 take out, integrate 1 over x minus 3. Okay, minus 1 over 5 take out, integrate 1 over x plus 2 dx. When you integrate 1 over, it will become, okay, when you integrate 1 over, got power at the bottom? No power at the bottom, right? Yeah, immediately it is just ln modulus x minus 3 minus 1 over 5 ln modulus x plus 2 or close plus c. Okay, so this is an example of when you see the quadratic, right? You have to see whether can factorize or not. If cannot factorize, complete the square. Understand? If can factorize, partial fraction. Okay, partial fraction is given in all your MF, so own self must be able to find out the A and the B. Then when it is partial fraction, then it will become a ln. Okay, so these are some examples. One more, which I always talk about one is this: the integral of sine square 5x dx. Okay, when you see sine square, which trigo formula you must think of? Double angle. So you write right here cosine 2a 1 minus 2 sine square a. Okay, make sine square a the subject. Bring to the left side is equals to 1 minus cos 2a divided by 2. So if a is your 5x, 2a is equals to 10x. Yeah, this will be the same as integrate half 1 minus cosine 10x dx. Integrate 1 x. Integrate cosine sine 10x. Remember to divide by divide by the differentiator of the angle. Or most of you like to write it as this way. Or integrate cosine is like 1 over 10 sine 10x. Okay? Plus c. Anybody don't know where does the 1 over 10 come from? All right, because differentiate of 10x is what? 10, right? Yeah, so it's 1 over 10. Or the integral of this. So these are 5 actually very good examples, okay, of the integration that you have to know about.